Kia ora. Let's see what we can find out from the molecular ion peak from a mass spectrum. So here's a molecule. This is its mass spectrum. And to find the molecular ion peak, you look as high as upfield as possible. That actually is a little bit of a impurity over there. And you'll find that this is the molecular ion peak in the assessment task that would have been pointed out as an impurity. So the peak, first of all, you notice is odd. That means there must be an odd number of nitrogen atoms present in the molecule. This little peak over here, if I can just get my cursor, is 1 unit higher in a 60:1 ratio, so very tiny. That is at carbon-13 isotopic peak. So we also see that there are even fragments, which is another indicator that nitrogen is present. So we know this molecule contains nitrogen. Here's one containing chlorine. So first of all, notice that the more abundant isotope is taken. So we count 35 rather than 37 when we work out the mass. And you'll see that they are over here. Notice we take the lower one as the isotopic, as the molecular ion peak, and the higher one as the isotopic peak, because 37 is not as abundant as the 35 isotope for chlorine. And notice they are 2 units higher. Notice that these fragments over here also contain chlorine because they also have this 3:1 ratio, 2 units apart. Although here these are 2 units apart, they're not 3:1 ratio, so these do not contain chlorine. Here's one containing bromine. Notice we have the same thing of 2 units apart, but now it's more or less in a 1:1 ratio. Again, we use the lower isotope of 79 rather than 81 because the 79 is slightly more abundant at 51%, whereas the 81 is less abundant at 49%. So this is our molecular ion peak, and this one over here at 138 is our isotopic peak. And you can see this these fragments also contain bromine, and those don't. Another reason why those won't is because the anything containing bromine must have quite a high mass, because bromine itself has a very high mass. Now here's our final one that we're going to look at in terms of what we can use, and this is the M plus minus 1 peak. So if that's my molecular ion peak and that's my isotopic peak, then this peak over here is the M plus minus 1 peak. I've lost hydrogen, which is quite common for molecules containing alcohols or carboxylic acids, aldehydes, or anything where you'd form quite a stable carbocation. So we could have lost that hydrogen there, or we could have lost this hydrogen over here to form a tertiary carbocation. So let's practice. What can we find out from this mass spectra? What elements are present? Now, hopefully you'll have a look and you'll see this middle tall peak must be the molecular ion, because that must be the isotopic peak, and this must be the M minus 1 peak. So we have a molecular ion peak of 87, which means nitrogen is present, and we can see that from this peak at 30. And another even peak here at 58. That's the isotopic peak, and that's the M minus 1, and that happens to be the molecule. So we know nitrogen's present, no chlorine, no bromine, and you must say why. And it's because we don't have 2 peaks, 2 units apart, in either a 3:1 ratio for chlorine or as a 1:1 ratio for bromine. Here's another one. Well, you can quite clearly see that 1:1 ratio, 2 units apart. So we know that bromine is present and not chlorine, because it's not in a 3:1 ratio. And we also know that the molecular ion is the lower one because of the more abundant one. So it's 122. So don't say the molecular ion peak or the molecular mass is 124. That'll be wrong. Okay. And that happens to be our compound over here. So bromine is present, not nitrogen, because it is not an odd number for the molecular ion peak, and not chlorine because it's not in the 3:1 ratio. Now here's like our first example we had with our molecular ion peak is the one in the middle, because this must be the isotopic peak, and that must be the M plus minus 1 peak. So again, we know this molecule could contain oxygen. We're not sure, but we know it doesn't contain nitrogen, chlorine, or bromine. No nitrogen because it is not an odd number. Um, yeah, and it is not bromine or chlorine because we don't have that 2 units apart in a 3:1 or 1:1 ratio. Now, if we have a look here, we can quite clearly see that chlorine is present because of that 2 units apart, 3:1 ratio. Remember, the lower one is your molecular ion peak, so the molecular mass is 78 and not 80. And there's our compound. So chlorine is present, but not nitrogen because it is an even number, and not bromine because it's not in a 1:1 ratio, 2 units apart. And here's something where it looks tricky because we've got something that looks even, but we know it is not bromine, even though they look like 1:1 ratio, and we know it for 3 reasons. First of all, it is very low. Remember, bromine is 79 and 81, so we haven't even included the carbons here. This molecular mass is just too low for bromine. Secondly, they're not 2 units apart, they're only 1 unit apart. And finally, it's a bit tricky to see, but this lower peak should be slightly taller than the isotopic peak for bromine, and it's the other way around. So this is our M+ ion, and this over here is our M+-1 peak. So all the best. Kia ora.